This conference will now be recorded.
All right.
All right, good morning, everyone. Thanks for attending our August meeting for the Tampa Bay Estuary Program Open Science Subcommittee. In the chat box, there is a link for today's agenda. And just to give you a brief overview of what we're going to do today, we'll skip over the introductions around the room portion so that we can make sure we get through all of our material and our discussions. So Marcus will lead off with some open science updates for Tampa Bay and their partners. And then it'll be followed up by 2 different presentations, and then we have a few discussion items at the end. So at this time, Marcus, I will go ahead and hand it over to you so we can talk about some of our open science updates for the estuary program.
Fantastic. So as per usual, I have hopefully not too many updates, but I'm going to try to get through them fairly quickly so we give plenty of time to our presenters. We've got, Mike McManus from the EPA talking about some of the work that he's done with some of his partners and hopefully facilitating science exchange to the use of open science. And then we have some of our partners from Pinellas County talking about their reclaimed water map application, and hopefully I want to have some good discussion around how that tool was developed, how it's used, and how possibly it could be expanded to other areas of the state. So that being said, I'll get through my update portion fairly quickly. A lot has happened in the last 3 months since we last spoke. A lot of Piney Point stuff, as I'm sure many of you have been involved in that. So I'll talk a little bit about that. But I'd like to start first with, again, reminding everybody about what this subcommittee is all about, what we do, how we try to bring open science to the masses. So again, this is part of our technical advisory committee technically, but we invite anyone and everyone that has an interest in open science to be part of this group. But we really have basically 3 main roles. Really, I kind of want to just use this group as a sounding board for how we can develop open science products, both internally within TBEP and how we can facilitate our partners to doing that as well. So I've often asked this group to serve as reviews for some of the products that we've developed, but also solicit input from you all for what are some priorities for moving forward of using open science to promote research to improve the management of Tampa Bay. And coming up towards the end of this year, we'll have some training activities that you guys can be a part of that I'll mention at the end of this meeting, of things to look forward to, and hopefully have this group sort of spread the word and facilitate those activities as well. You can always check out our guiding document right here that sort of lays out in more details what this group is all about. The first update, last meeting I talked about the Piney Point monitoring dashboard. We continue to develop this dashboard. This is a tool that was developed early on to really get the data out there as fast as possible to show what's happening to the bay with the over 200 tons of nitrogen that was discharged as a result of the emergency order issued to the Piney Point facility. So that's been out there for a while. We continue to add data and update the features. What I want to draw your attention to now is that we actually put out a video, a YouTube video that shows how to use this thing. It's a short little 10-minute clip. You could watch it at your own leisure. I don't want to show it now because it's a video of me looking super cringy and talking about how to use this thing, but this is something that I maybe would like to do for some of our other dashboards, because I know that there's been a lot of interest in some informative tools of how to use these things in a way that actually sort of guides you through the different panels and shows you what things to click on and all that. And so given that this dashboard is very popular, it's about, used about 10 times more than any of the other dashboards, we thought this would be a good use case to show, or at least develop a video that sort of walks you through how to do this. So I invite you to check out that video, any feedback in terms of how well we communicated to you, things that you thought may have been missing, because it's something we could do for some of our other dashboards. A big part of what we do in the Open Science Subcommittee is develop dashboards as a communications tool, and we have many other platforms we could develop similar videos. So have a look at that, just to let you know that it's out there and available for viewing. The other update I wanted to mention is a topic that's not necessarily super relevant to this group in terms of the actual content, but how we have delivered some of the products around that. So over the last few months, I've been working on making our Habitat Master Plan update more open sciencey. So if you've heard us talk in the last year at all about any of the Habitat Master Plan stuff, you know that we've been working on this for several years now. The Habitat Master Plan is something that we use as a program to sort of prioritize where we focus efforts for habitat protection and restoration. We do an update every 10 years. And so last year, actually 2020 in July, this was released, this 10-year update. And so this was a great effort to sort of take stock of all of the habitats that we have in our watershed, going from subtidal to intertidal all the way up into the upper watershed, looking at what the habitats are that we have, taking stock of them, looking at current counts in terms of acreage, what the trajectories are in terms of what the habitats are that we want to protect and restore, and then laying a plan moving forward to identify what some goals are looking forward both up to 2030 as well as 2050. So sort of a long-term reach in terms of where we want to focus our restoration and protection efforts. So this was a great tool, but we wanted to be able to have reproducible workflows to update progress towards updating where we're at every year in terms of what we're working towards with these goals, because new data layers come out every year. The land use land cover layers get updated fairly regularly. The seagrass layers get updated, and we wanted to make sure that the maps and the tables that were in that original Habitat Master Plan update document could be updated easily and communicated in a way that our partners could easily digest that information. So what I've been doing the last couple of months is focusing on developing these so-called evergreen products for the Habitat Master Plan update. And if you remember, we had a presentation last time from Ben Best and Tyler Murray talking about these evergreen products, where the idea is what you see online or what maps or tables you see is actually fed by the most current data set that is available. So there's a lot of steps that go from raw data to targets and maps and stuff like that. And so we wanted to make sure that we had a reproducible workflow that was coming out of that Habitat Master Plan update document to ensure that what people are viewing is reflecting the most up-to-date data. So we're working on workflows to do that, as well as putting the data online on our website for our partners to digest that information in a simple way. So if you go to our website, so if you go to this link, the Habitat Master Plan update, this is sort of the landing page for everything related to the HMPU. You can access the main document here. We have a nice story map that lays it out in a easy to digestible format. But if you go scroll down a bit, you'll see these links down here. And so it's basically this high level summary of where these sort of opportunity areas exist for different restoration or protection goals we have for different habitats in our watershed. But if you click on the map, you'll get a link to summary information that's broken down by total watershed, as well as municipalities or municipal units of interest that are basically where our partners could take this information and use it for some actual boots on the ground prioritization of where these restoration or protection acquisition projects could take place. And so we have tabular summaries. So this is an HTML table looking at the different habitat categories as defined in the HMPU document. We have maps showing the same thing. So this would be the whole watershed. Then we've got it broken down by jurisdiction or municipality. So somebody from Hillsborough County, for example, would only be interested in the opportunities in their county. So we've broken it down that way. And so this might not look all that groundbreaking, but all of these tables and maps are actually fed by a workflow on GitHub that pulls in the data from the source, essentially, the land use, land cover layers from the district, or the acquisition layers from Florida Forever. All of these data sources that feed these tables and maps are pulled in automatically. So anytime each one of these things are updated, we can just drop in that data set, update the tables and maps in kind, and essentially what you're seeing on the website is evergreen so that it's reflecting the most current state of the data. So this obviously has benefits for saving us time. I'm having to do this every year or whenever the data gets updated. We just drop it in there. And so the most timely information is provided to our partners. So we've been working on that again for this group. You know, whether you have an interest in habitat management depends on where you're from, but this is an open science group, and I just wanted to emphasize that this is a useful way to conduct business, or science rather. So applied science, making sure that the science gets to who needs it, and the data they get is updated, reflecting the most current information. So this is the value of that. You can check out the full presentation here. I actually gave this presentation to the Habitat Management Consortium, which is another group that we facilitate through the estuary program, but you can see the details there by going to that link. So these are philosophies and ideas that we try to bring with open science. We've also, in the last actually 2 weeks, we've been doing a lot of updates on just bay indicators in general. So now just going beyond to some of the other indicators that we focus on. You've actually seen a lot of these products in the past over the last year through subcommittee meetings. So we have tidal creek indicators, we have fisheries indicators, we have benthic sediment condition indicators. We routinely get updated data from our partners to update these products every year. And so we recently got 2020 results for the Nectin index that are now reflected on the dashboard, thanks to Megan and the whole FIM crew there. We actually also got benthic sediment data updates from EPC. That's got more of a lag because there's a lot more processing that goes into that data set. But now we've got the benthic report card updated on our website as well. And then also with tidal creek assessment, this is work that's been going on for several years now, but through the efforts of our partners, a lot of the NEPs in Southwest Florida are involved in this, Janicki Environmental. So Mike Wessel actually got a paper published last month, open access paper through Estuaries and Coasts that describes the process for how we developed a report card for reporting on tidal creek indicators. So you can check that out. We've also been doing a lot of updates to the dashboard there as well. So I just want to draw these new updated products to your attention to sort of check them out and see the latest state of the data in terms of how we're reporting on these different indicators for the bay. There's also been a lot of good training opportunities available to you, not necessarily specific to the Tampa Bay region, but just more general. Ben Best from NOAA, remember he talked last time about some of his work, but he's been doing a lot of cool trainings that's been going on the last couple of weeks. He's actually been doing this weekly, giving about an hour and a half training every Monday on different topics. So you can go ahead and check that out. This is sort of a tour de force of everything that's related to open science and these nice little weekly modules that he's put together. Ben's been an inspiration for me in terms of how I try to develop open science. So a lot of his philosophies, speaking of open science, are probably echoed in these meetings as well. But it's fairly high level in terms of what you can do, or the level of teaching that he's gone or provided here, but nonetheless, it's a good sort of introduction to what you can do with open science, sort of covering all of the topics from, you know, data analysis to reporting and dashboard development and all that fun stuff. This one here as well, this is I believe I want to say USGS tutorial, but I've worked with some of the instructors from this course in the past. Definitely very talented folks and excellent instructors as well. But This is more focused specifically on ore, but topically oriented towards water resources management. So I've heard a lot of good things about this topic for this course. So I encourage you to check that out as well if you want to brush up on your R skills. And then, yeah, that's all I have for updates. When we're done with our presentations today, I want to talk about scheduling for the next meeting, also how that relates to some of the other open science trainings we're going to have at BASIS and SURF, and maybe thinking about canceling our subcommittee meeting in November in lieu of the trainings that are going to be happening later this year. So we'll touch on that towards the end of the meeting. So I want to make sure that we have plenty of time for our presenters. So before I hand it off to Mike, I want to just briefly check if there are any questions about any of those updates that I just rapidly went through. All right, so I'm not seeing any questions in the chat. Yeah, so I guess I will hand it off to Dr. Mike McManus of US EPA ORD at this point. Gotta make you presenter, Mike, again, I believe.
Sure.
So Mike will talk all about this, but he and I, after the last open science meeting, thought it would be good for him to present about some of his work with the EPA, focusing on collaborative open science tools to do better science in less time. So I'll make you a presenter, Mike, and you can take it away.
All right, let me just start sharing. Okay, so did the PowerPoint show up?
I'm still seeing in presenter mode.
Yeah, I do that.
Okay.
Switch again.
All right, that looks good.
All right, thanks everybody.
In the
All right.
go-to meeting bar on the right side as well. You don't want to move that.
All right.
Perfect.
No, just 1 second. Let me get. How's that looking now? Okay. Let me get this going. All right. So yeah, I want to thank Martha for this opportunity and describe an ongoing project that we're trying to do open science. And so, as you've seen by some of the TBEP dashboards, open science products can look very slick. They can have lots of graphs. They're interactive, where you can shift the looking at data points or looking at trend lines, and they can automatically update. So, in the hands of an open science professional like Marcus, some of these products can look like a sports car. They're very responsive, they're very colorful, and they can be very complicated. So if you're just starting out in open science, maybe you don't want to get the keys to a Lamborghini, which is what Marcus is driving. Maybe you're more comfortable looking at starting out with, say, a minivan. And so if you're just starting with open science, you don't want to get overwhelmed by it. And that's what I'm going to talk about today, is starting an open science project with partners. So I'm going to start with a diagram you've seen before about conceptualizing with open science, and this whole open science workflow from beginning to the project, going all the way to publishing in open access, such as the paper that Mike Wessel's just published. And this is the process that I'm using, but I've actually made an addition to it, into one of the steps, because of starting this new project. What I've done is added a step here of documentation. And I've started that because of a project working with the Indiana Department of Environmental Management and the EPA Region 5 office, which is our Midwest office based out of Chicago. And the reason I inserted that document step is, beginning a project, everybody needs to start to get familiar with the data and how we're going to look at it and its analytical workflow. So that's what we needed to work out in these first two steps of conceptualizing a project and then starting to design, collect, and analyze the data. And I'm going to present the conceptualization of the project and then move on to some of the open science tools that we're using to get the work done. And the intention of the project is down here at the bottom. The big overarching goal is to make statewide predictions of total phosphorus concentration throughout all the rivers and streams in Indiana. So I began working with the Indiana Department of Environmental Management and with the folks in EPA Region 5 to make these predictions. But to get to this goal at the bottom, what we're having to do is start with the data sets that are all up at the top. These are data sets that an environmental agency typically might have. On the far left are the trend and fixation monitoring stations. These are stations on rivers and streams that are typically located downstream near a watershed outlet. Then in the middle, there's often another type of monitoring data set collected are spatially balanced probabilistic surveys. These are basically random samples taken from the river and stream network. And by taking random samples, then when you're calculating your averages or your medians of total phosphorus, it's giving you an inference of the population of streams and rivers in that watershed. And then the third type of data set is a targeted or intensive studied watershed. These are often motivated for a variety of reasons, such as total maximum daily loads or other evaluation projects, such as looking at EPA 319 projects. So we've got to bring all three of these data sets together. Often they typically are siloed, but we're bringing them all together to accomplish a number of things. First off, this gives us a larger sample size, but more importantly, by bringing the data sets together, we're getting better spatial coverage from headwaters down to the outlet. So we're getting a nice spread of points along the stream network. And we're also getting a clustering of points of stations that are near each other. What this is allowing us to do is we can take advantage of spatial autocorrelation. That is, sites that are near each other are often going to be similar in their total phosphorus concentration values. Taking advantage of that similarity or spatial autocorrelation, we can model that as a function of land cover in the watersheds, and then using that spatial autocorrelation, make predictions to the unsampled locations. So this is one of the open science approaches we're taking, because that entire analysis is done in R. And as an outcome of our project to producing these predictions, we're going to be providing the data, the annotated code, and the results in an accessible format so that our research approach is transparent, reproducible, and more importantly for this project, transferable. Because after we do this analysis on total phosphorus, we want to be able to give that analytical workflow to Indiana Department of Environmental Management as they're involved in learning about this, so they can decide if they want to make predictions of total nitrogen concentration, they can do that in the future. Or if they want to make a prediction based upon a biotic indice, they can do that same approach. And so here are some of the folks that are involved in this project. It's a multi-agency project with a lot of different expertise. We, of course, have the scientists at the Indiana Department of Environmental Management. This includes the project managers of those different monitoring programs, but we have ecologists and data analysts that are modeling and collecting that actual monitoring data, in addition to GIS analysts and chemists who are making the estimates or measurements on total phosphorus concentration. So we've got that component. I'm with the EPA's Office of Research and Development, or ORD, and I'm working with Indiana, but also we're bringing in spatial ecologists from the U.S. Forest Service, as well as a spatial statistician from NOAA to help us with the analysis, including some contracting statisticians. And then we've got the EPA Region 5 staff that have the connections to all the states in that region, so we can help disseminate these projects for this type of work, which is called a regional applied research project, or a RARE project. So we've got lots of expertise. We've got lots of different backgrounds, experience in open science. And so we need to be working together. And here is exactly what is not to do. is do not hand your partner the Hampton paper about the Tao of Open Science. It's a great paper, but it has this awful table in it. It has this table of, you want to do open science? Well, here are over 50 tools listed in this table that goes on for 2.5 pages. Marcus doesn't even use all these tools. So you don't want to hand him this long list of, this is the opportunities we have for doing open science. Instead, we took a step back and really focused on the fundamentals. And by fundamentals, I mean down to the level of what did we learn in kindergarten? Because the two guiding principles that we're making use of is sharing and show and tell. So the open science steps that we're starting with is, how do we share our data? How do we share data such as flat files of the water quality chemistry data? How do we share the spatial data? How do we share our code? And the second kindergarten aspect of show and tell is, how do we display our analytical workflow? How can we show what we're doing so that people can be familiar with it? And actually, when we answered these questions, we answered them on the basis of accessibility and familiarity. And what we came up with is a hybrid method. It's hybrid in the sense that we are making use of some commercial data software because it's readily available, but we're also making use of open science tools. And for sharing, we're making use of a OneDrive folder that I'll pull up in just a minute, that everyone has access to, so that's where we can share our data and make notes about that. And then for displaying it, we're making use of our Markdown and our Studio so we can create HTMLs of that workflow. So I'm just going to get out of the PowerPoint just to bring up some of the other tools that we've got. And as I said, the OneDrive was actually the simplest thing to set up. We set up a data folder and everybody has access to it. So the US Forest folks, NOAA, the folks at Indiana Department of Environmental Management, we can all get in there. And that's where the data are stored along with our code that everyone has access to. But most importantly, we're able to actually create a running record of what's going on. And so working with total phosphorus data or water chemistry data, it's very common where you have observations that have detectable levels of total phosphorus, but then you have non-detects. Sample that was taken that is actually below the detection limit of the instrumentation. And this is a series of questions I had to outline to the chemists involved, specifically to Charlie and Tim, and said, here's how we're going to handle the detects and non-detects, and laid it out to make sure that I understood their data and how they interpret some of their QA flags. And not only could we just put that right here in a Word document that everyone could see, but more importantly, we could actually put that in our code. So I'm now just over in our Studio. We've seen this before, but we can, make use of our Studio and its formatting that lets us put in just regular text, such as this background here of what this code is about to do. And then we can get down to the gray chunks, which is the actual code. And by having it in this format in our Studio as an R Markdown file, we can knit this, and we can knit it into an HTML. And so that's what's showing up right here is the current HTML that's describing the Indiana Department of Environmental Management, that's item, and the exploratory spatial data analysis, the ESDA that I've been doing because I need to get familiar with these data. And what's wonderful about the HTML format is we can just provide this very easy table of contents along the side. So for example, you can see I'm describing each of the different types of monitoring data we have on the probability surveys, the fixed stations, the targeted stations. And so we can organize this in a way that people can follow along. How was I getting familiar with the data? What questions did I have? And then we're able to look at some of the spatial data. And so we're able to, for example, show where are the monitoring stations in Indiana, and they're grouped by these 9 watershed basins that they use as part of their monitoring design. And so this is something that the RIS analysts can look at, and we can look for possible spatial outliers, a station that perhaps got assigned to the wrong location. Another aspect of the spatial data that we have is that it's collected over survey cycles. And so there's a survey 1 cycle where the data were collected, and then a survey 2 cycle, and so forth. And so we want to look at that spatial distribution over time. So the next map I'm going to show you is an animated map. I just want to let people know animations are coming up because actually in my job seminar at EPA, I showed an animated map one time, and I learned later that it made some of the people in the room nauseous. So animated maps can make a few people motion sickness, but I don't think that's going to happen here. As I said, these surveys are done in different cycles, 1 through 5, and that's what's being displayed here are the different survey cycles and where those samples were taken. And you can see that during some periods when there are intensive monitoring in some watersheds, you see a real cluster of points come up, such as up here near Lake Michigan. Now, these 2 displays of spatial data have all been on point data. And looking at points is fine, but it's a little overwhelming. And so we've made use of something called linked micromaps, which are a way to summarize both spatial and statistical data at the same time. What we have here is a 5-number summary or a box plot of our total phosphorus concentrations. They're very skewed, as you can tell, because we have some very high concentrations, but most of the data are quite small and are lower concentrations, so we just transformed them to make a box plot here that's more spread out and easier to see. And a linked micromap provides a way to link the basin we're looking at, the Great Miami, with its red box plot and its red location, or the lower Ohio. We can look at a blue box plot and see where the lower Ohio is. And what's interesting about this is, even though Great Miami has some of the lowest concentrations, it has some real outliers. And then down here is a watershed, the Patoka, that's showing much higher concentrations compared to some of the others. So using the OneDrive and using an HTML that we generate through our studio lets us do this open science that has some real benefits. And so I'm just going to end on this slide. And, what we're doing with this geospatial project is we want to produce maps of predicted concentrations so that Indiana can identify possible hotspots of total phosphorus and introduce remediation to try to address those areas, but also producing prediction maps. You can find areas that have high uncertainty. Where do we get large prediction intervals? That can suggest that's an area that needs more sample stations put in it to try to produce better predictions. And using the open science approach, the benefit is it's transparent and reproducible, but in particular, it's going to produce a transferable product. So this hybrid method is what we're doing. I would love us to get to using GitHub for all of our data management and tracking of issues, but this hybrid method was something that got us up and running in a quick manner. So with that, that's it for the presentation, and I'll see if Marcus, if you want to do questions now or wait till the end.
We got time to do some questions. Are there any questions from Mike?
Hey, Mike, this is Chris Anastasia. I'm with the Southwest Florida Water Management District. This is a really good presentation, and I can see, a lot of applicability in other systems and in other parameters, like you were saying with TN. I think that'd be really interesting how it's applied with total nitrogen. I just had one quick question. When you were showing the predictive maps and you were showing it at the watershed level, and I may have missed this, but the locations that you guys are, or the data that you're using, those are all surface water samples that are in the mainstream channels, but as well all the tributaries. Is that correct?
Right. So that's a great question, Chris. And actually what you're seeing are the observed data. We haven't finished building the models yet. We're just getting underway, but the important component that you picked up on is that spatial distribution of sites, is that we need that combination of sites in small stream systems, the headwaters, but also tributaries, and then down to that outlet. This is that type of distribution of data spatially over a river and stream network is what's going to let us do a spatial stream network analysis. And that's the type of R package that we're using so that we can do the interpolations between, we have observed data all along that network, and now we can make predictions within that network and come up with an overall average. So we can compare, here's the average total phosphorus in the Patoka that we predicted. How does that compare to the average total phosphorus in the Great Miami? So you're right, we need that spatial distribution over all types of sizes of streams and river systems.
Yeah, and I was thinking in terms of looking for hotspots. I think that this is a great tool that could, even within a watershed, you can potentially see those, like you were showing how the data are skewed, which is not uncommon in environmental data, but you could maybe, pinpoint or isolate potential areas. That what I really like about it is the idea that you can drive future monitoring, because that's something that we're always looking at, is how do we optimize our monitoring and get away from just your typical fixed station monitoring where you have 3 or 4 or 5 locations and you just keep going to those places. There's a place for that. Like I liked your table that you had at the beginning, where that is a good a good construct for monitoring long-term trends, but you may be missing, the hotspot, which may be somewhere that you're just not looking at. So I think this is great as not only as a potential prediction tool, but also as a good planning tool.
Yeah, and that point of, where are you monitoring? And that's why one reason I'm working with Indiana is that they've been doing the spatially balanced survey designs for over 20 years. So they've been making that random draw over their stream network that really is hitting a lot of sites that will clearly be missed if you just rely on those fixed stations. And we're seeing, of course, that not surprisingly, the types of data you get are very different from the different systems. The downstream or those fixed station sites readily have concentrations that are quite high all the time. But what we're seeing is we get a lot of non-detects in the smaller systems. And so we're having to wrestle with that issue. But you need to be able to integrate both spatially, but also the different types of systems that you're monitoring. Like you pointed out, the trend stations are going to tell you something very different than stations that are further up in the watershed.
One last question real quick. What's the timeline for completion of this project to where you can start looking at those predictive scenarios?
We're just hoping, I think by next spring. This project just got underway in January. And so I've been working on the data side, and we're just bringing on board some of the other folks to help with the project. So I think we can get our first set of predictions by spring. That's going to be great, fingers crossed, because of course, what we're going to do is make use of the upcoming monitoring season where they do a random draw of where they're going to go. And we're hoping to be able to say, well, this is what we're going to predict you're going to see. So we're going to use that upcoming monitoring season as an independent check of how well our predictions are doing.
Very cool. Well, thank you. I look forward to seeing that.
Yeah, we could talk some more about this offline, but thanks for the interest.
Any questions for Mike? Well, I have a question actually. Well, maybe a point more than a question. One of the reasons that I wanted you to talk today, Mike, and this also relates to the second talk we're going to have in a minute, is I wanted to have a focus of this particular meeting being on how to collaborate in a way that is maybe much more accessible to people that have never used open science before than, say, like you actually mentioned, handing them the Hampton and all paper and saying, do this. So, it's difficult to look at that table and know where to start, is a point that you made very well. I'm curious if you could comment a bit on potential challenges or how able the colleagues you were working with, they were able to pick up some of these tools? You know, because you talked about, you worked with, you know, engineers or technicians or people that are just maybe not scientists or have any formal training in open science. You know, people speak different languages. You know, was it difficult even bringing them up to speed with, say, here's an HTML, we can use this, or what other?
Yeah, I think what helped a little bit is that some of the team were already familiar with R because of that spatially balanced survey designs is readily used by agencies quite a bit throughout the states, including state agencies and the EPA. There were some folks clearly that had familiarity with R, and so that was a help. What also provided a bridge was being able to work with data that people were familiar with, such as the GIS analyst was, you know, making use of ArcMap and Esri products, which are very good. But I was able to show, you know, look, we can also produce these maps in R, and what the benefit, and I had to articulate the benefit of doing this, is that lets us maintain a continuous workflow of the data are brought in. We can display them spatially. We can then do a statistical summary instead of, okay, we've got some of the data here, and now we're going to pop out to ArcMap because now we want to look in ArcMap, or where are those points located? You can do that, but it disrupts the workflow because then everyone has to have, well, do you have ArcMap on your device? Do you have access to that? And so pointing out the continuity, I think, is a real benefit, and that it's being able to work with a variety of type of data sets within one system is a real advantage. And doing open science in that manner, I think people start to see this advantage of having a common analytical workflow instead of jumping from software to software and then asking, oh, do you have this version or do you have that version?
Yeah, and versioning is still an issue in R, but your point is well taken. I mean, I definitely drank the Kool-Aid many years ago where I'm like, I got to stay in R Studio because anytime you flip back and forth between different platforms, it's not only tedious, but you open yourself up for, you know, copy paste errors or extrapolation errors, whatever you want to call it. The last question I want to ask, if we have a few more minutes, but it's kind of related. You know, one challenge that I always encounter is, you know, when you work with partners or collaborators, and you know, you're, I guess, the one primarily leading the charge for open science and maybe different workflows that people might not be accustomed to. I personally, I try to instill like this sense of ownership over the products so that, you know, you are not necessarily like totally tied to working with your partners as, you know, the necessary like linchpin to making sure that they can do the analyses or whatever. And so you want to transfer ownership and sort of lead by example and motivate them to adopt these new tools. Have you found that to be in this particular example? If you're still working on it, then I guess it's TBD, but have you been able to transfer these tools effectively to your partners so that they can, you know, learn from them and adopt new workflows so that they can continue to improve on them in a way that is efficient?
Yeah, so I've done two things to try to address that transferability. One is, you know, posting the code and the HTML together so that some of the analysts at Indiana can actually look at that and try to do it on their own. The other is actually taking advantage of one of the trainings that you've mentioned. Is I actually forwarded the training that Ben Best was doing to some of the folks in Indiana, and I know they signed up for it. So I think what we're striving here is to get enough of a common background of experience to make that transfer or that handoff possible. But that requires focusing not only on the project itself, but what are the skills and capabilities needed to carry on that project to, you know, another indicator. And so that's where you've got to provide it both with ongoing, as you're developing the HTML in this case and saying, hey, this is how I brought in those interactive maps and this is why they're helpful, but also looking out for other opportunities for them. And And I think the real challenge for this project is going to be bringing both the geospatial and the statistical side together. This type of modeling is very powerful, but it requires both skill sets. And so I'm hoping as we get more into this project, that particularly the GIS analysts will step up and say, well, I know I could do this in ArcMap, but is there another way I can do this and to build the spatial stream network data structure we need? So part of it is learning by doing or by showing, but also providing the resources. And I made a point of signing up for Ben's course. I was able to get to a few of them, but I wanted to show, one, that I was interested in them learning and letting them see my interest in it, but also that way, if they get stuck on some of the training materials, I can look at it as well and say, okay, Ben did it this way, maybe here's another way. So it's providing that resources and showing the commitment of, we need to learn this together so that you can do this in the future on another indicator or another analysis.
Yeah, that's a really important approach, is sort of creating that environment of shared learning is a very important way to not just transfer workflows, but instill a capacity for continued learning. And so that it's an uphill battle, as we know, with open science tools, because the toolbox is large and the toolbox is always evolving. But the more we can meet people where they're at and invite them to learn on their own, I think we'll be much better off. So anyway, I really appreciate the presentation, Mike. Thank you so much for giving that. I want to make sure we have plenty of time for our other presenters. So we'll jump to a presentation from Pinellas County now. And we've got a few people on the line from Pinellas County. So we're having a presentation first by Anna Marie and Ryan. So I believe Ryan is going to do the screen share. So I'll have to transfer control. So I just sent that your way, Ryan. And they'll tell you all about their reclaimed water mapping tool. But I saw a similar presentation by these folks a couple weeks ago. And this is a fantastic tool that I think opens the door towards more transparent sharing of information to the public. And I want to use this as an opportunity to understand how the tool was developed and how possibly this group can move forward of maybe improving its functionality or bringing in other partners to share their data. So with that, I'll let you guys tell us all about it.
Okay, great. Good morning, everybody. You hear me okay? Excellent. Thank you, Marcus, for the invitation, for the opportunity. I will say for myself as an individual, this is my first experience with the open science as an option. So super excited to be here and see how we can collaborate further. I'm the section manager for the watershed protection section for Pinellas County's environmental management, and Ryan Reisig is the environmental program manager over our fertilizer and landscape maintenance ordinance program. So this tool was essentially developed for that program as an opportunity to expand our outreach. And it was done through our GIS specialist, Rob Burns, created the first version, what's existing right now. And then Daniela McDougall was brought in to work with Rob Burns, and the two of them are developing what is our version 2 of this. And it's that version 2 that we're looking to provide some opportunities to others to have this type of tool available and expand on outreach. We've had this map in place, our fertilizer ordinance. I'll give a little bit of background. Ryan, if you want to go to the next slide, and can you put it on presenter mode, because we see the teaching notes at the bottom. That let you click that.
I didn't realize which screen it was on. Is that good?
There we go.
Okay.
Yep, perfect. So a little bit of background. Should go to the next slide there. Okay, so through the assistance of the Tampa Bay Estuary Program, Pinellas County adopted our fertilizer ordinance back in 2010. And since reclaimed water was identified as a source of nutrients, I think it was about 2013 that this map was discussed as a way to identify how we can get more information out to our citizens. Pinellas County has multiple reclaimed water providers, service providers. So we have various treatment levels from secondary wastewater treatment to advanced wastewater treatment. And we identified that as a gap of what we needed for outreach was to be able to provide one easy place for professional applicators was our first intention. And now just general residents, citizens to find information about reclaimed water. So of course, reclaimed water does already contain nitrogen and phosphorus. So every time somebody is using reclaimed water to irrigate their landscape, they're already putting down nutrients. So Pinellas County does have some impaired watersheds, and we are trying to address the nutrient reduction. So providing this education to folks so that they can make those best practice decisions on reducing fertilizer use. And knowing how much nitrogen is already in the reclaimed water that they're using. It depends on the provider where their reclaimed water comes from, and then how much more nitrogen can they apply to reach the University of Florida IFAS recommendations for grass type without exceeding the restrictions of the Pinellas County Fertilizer Ordinance. Next slide. So as part of our data collection was, of course, to continue to partner. We have a great partnership with the Pinellas County Extension. So getting that information from them on the nitrogen recommendations by grass type, for one, and then also irrigation recommendations. So we want to make sure that we're putting those two pieces together. The third piece was the various providers and their service areas. So City of Clearwater is one service area, City of Largo, City of St. Pete. So initially obtaining that information from them as to what their service area is, and then digitizing the maps to make the shapefile polygons so that we can display it in that regard. Then there's getting the data that's going to show in the polygon. So those conversations with each service provider to find out what their concentrations of total nitrogen are, and then doing the number crunching in Excel in the background so that the proper data can display in the service area polygons. So there was a lot that went into the data collection piece, and we're constantly refining that, tweaking that, and we'll go to the next slide here. So this will show you the existing map. This is what's available right now on pinellascounty.org/fertilizer. It is an interactive map. Pinellas County does have Esri, and Rob Burns did pretty much all of the original development of this map. And so it's by polygon. So when you click on the polygon, it gives you the numbers that are in the Excel file in the background. So for the example that's shown here, for the City of Clearwater, it shows that there's so much nitrogen that's incorporated that you can then additional maximum you can add per grass type. The first number there is Bahia, the second number is for Bermuda, the third number is for St. Augustine. On the version 2, we're also incorporating zoysia because it's a common grass in the area as well. So on this first version, at the time that this was developed, again, 2013, 2014, the UF IFAS recommendations for irrigation were 1 inch of watering. And so we were using the mean concentration of the nitrogen from the wastewater treatment plant, along with, you know, that recommended 1 inch of watering. And then if you follow that throughout the year, you have an annual nitrogen load, for which we subtracted from the recommended grass types and provided, okay, here's your maximum of what you can add without exceeding the ordinance. So lots of number crunching went into there. And this map, like I said, has been in existence for a few years. And just a couple of months ago, received an email via Pinellas County Extension that somebody from the Water Management District from SwiftMud had reached out to the extension going, hey, we like this map. We'd like to make this more regionally available. Would you be willing to talk to us about exactly this, how you developed it, what went into it? So from there, it actually went from SwiftMud to DEP. So now we have the state interested in a potentially statewide map application. So kind of not one application, but trying to see how we can kind of lead by example. Like you said, Marcus, in the previous discussion, was we have this tool, we use Esri, it works for us. Not everybody has Esri, so that's when Marcus was in that meeting, he's like, hey, we have this TBEP Open Science Committee, maybe come talk to us, show us what you got, and see what's what. So Ryan's going to take over the presentation, and he'll kind of go through version 2, which is what we're in the process of updating, and that will be available. We're looking to go live probably October. We're not ready yet, still getting numbers and getting updates to the shape files and things like that. But we do have this publicly available right now just for this purpose of this presentation, to be able to have you guys take a look at it, click around. After Ryan does his presentation, Daniela, our GIS specialist, she's going to do a demo, kind of run through a couple of clicks on the screen so you can see it, but it's also going to be available until 10 a.m. tomorrow, just so that you can kind of play around and give us some feedback and see what we can do to further collaborate and provide this tool to others outside of Pinellas County, because there definitely is some interest for that. And with that, I'll hand it over to Ryan.
Hi. So our new updated map, we added a few things based on feedback and just information available that has changed over the years. So one thing we incorporated was some information for applicators that had been requested, particularly from the golf courses, was the nutrient concentrations. Hadn't been on there in the past, so we started adding that even to the current map that wasn't on there before. And then we provided a range. We're providing a range in the new map of the min and the max nitrogen concentration instead of just the max, to correlate with that limit recommendation by the University of Florida, and also to let people know you don't have to fertilize the max. You can fertilize it less than that as well, as long as you have the response you want out of the grass. We'll update the water recommendations that you're talking about. So that's been reduced to the maximum recommendation of 3/4 of an inch. So that's what we're basing these calculations on, because the 1/2 inch to 3/4 inch recommendation. Updated service areas. Some service areas needed some correction because it changes over the years. They expand areas. We got more information about areas we were missing, things like that. And then provide web links to different providers' web pages, so we can add that information in that wasn't available or able to be done in the old map, because there's more space available. And then provide also links to more educational materials and other best management practices they can do in addition to this. So here's what the new map looks like. You can see we have that big space on the left-hand side that we have to be able to put additional information that wasn't available before with the little pop-up windows in the previous version. So we did some explanation as to the impact of nutrients on water quality, why it's important to fertilize correctly, some of the basic limits per the ordinance, and on application rates and restrictions during the summer rainy season is in there, and then some links to more information, ordinance summary, and things like that. So we also were able to update some of our current numbers, so we want to do that too. We want to do that, start doing that on a more regular basis, getting those annual averages from the reclaimed water service providers, and be able to update and keep that up to date. And then the main thing was replacing that max with the min and the max rates. So with that information, we actually have a spreadsheet which calculates it for us that we set up. It's based on we enter the concentration and milligrams per liter, and then it'll convert it to pounds per gallon. And then we're multiplying that by the number of gallons per year applied to that area. And that's assuming that 3/4 inch per watering, twice a week watering per IFAS recommendations. And so that kind of gives an idea of how much nutrients are being applied to that property per 1,000 square feet, and then we can adjust our numbers from there based on the loading of the pounds per 1,000 square feet of nitrogen per year. And so that feeds in this other table, and we get the information here, and here it gives the grass types, and these numbers are basically the recommendations for University of Florida. For example, Bahia, be 1 to 3 pounds per 1,000 square feet for Central Florida is recommended. This go ahead and removes that half a pound that was calculated into that. That's already been applied versus for application based on the application rate we did. For example, the City of Clearwater first one, and then so you get those min and max numbers reduced to what should be the min and max accounting for that. So the replacement map, here's what happens when you click, you can search it via your address, or you can click on that area from the map. Either way, you can get to the area where your service provider is covered. And then it gives them some more information. When you go down to this level, you get the pounds recommended by University of Florida. Explanation of the concentration is going to be in here. We're going to add that in. You see it says coming soon right now. And it's based on the loading rate will be there. And then you'll also have the, right now it's just the max is in there, but we're going to give that range for the amount of more fertilizer you can put on and stay within the limits per the ordinance and following the recommendations. And then, but again, we reiterated the restriction on the application rates and time of year here to make sure that was known to the customers, and that we also added a disclaimer per the request of some of the service providers to say, just because this is a service provider area, doesn't mean you may have a tap for reclaimed water in that area. So even though it shows reclaiming your area, it may not have it available to you. One of the other benefits of this was when you put in your address and search it, if you're not in a reclaimed area, it will actually kick you back to the website and have other links for information on other best management practices you can do and follow, and information about fertilization and nutrient pollution if you aren't in that area. So we got some feedback from our meeting the other day, and we're trying to think of a good name for the title of this. Right now it's reduced fertilizer when using reclaimed water. Here's some, we got some other titles we are kicking around. Fertilizer needs when using reclaimed water to reduce fertilizer use. Reclaimed water reduces fertilizer needs. Just trying to make it as simple, as short as possible while describing what it is and kind of the goals of it. So if you guys have any ideas or suggestions, it'd be great. Still trying to work that out. But also maybe some pros and cons of visual approaches, or more guidance on fertilizer application that we could link or add to this would be great. Any feedback on that? And then also we're looking at sharing, like make up a SOP and a template, Esri template. They'll be able to share tips and tricks and kind of a guide on how to set this up for other municipalities or entities that want to share this information in a similar manner. So if you have any feedback on how you'd like to see that happen, that'd be great. And we'll try to be able to provide that. And then messaging to enhance our audience. Our audience is basically residents and then applicators. So any particular messaging that would be beneficial, or avenues for contact. We do a lot of that already, but any ideas on that would be really helpful. And if you have any questions, please ask. Are we going to take questions now?
We can take questions now. I'd like to give Daniela an opportunity to kind of do a show and tell, a demo.
Okay.
So Marcus, if you can, yeah, we'll do that first, and then we'll see the time that we have afterwards for questions.
Okay.
Yeah, that sounds like a plan. I'm going to pass it to Daniela right now.
Perfect.
Hi guys. Let's see here. Okay. Just want to make sure you guys can see my screen.
Yep.
No, not yet.
I just saw it. I think we're seeing it now.
Okay. Okay, wonderful. All right, so hi everyone. I will just be doing a quick demo, just basically highlighting what Ryan just talked about. So as soon as you access the application, this is what the home landing page looks like. You are able to, toggle on and off, or I guess hide the legend here, if you'd like to. On the left-hand side, like Ryan said, you have a welcoming educational message, talking to you about what the intention of the app is and benefits of using reclaimed water appropriately. There's also a link down here that opens up into a new page giving you other information about the ordinance. Then it transitions into how to get started using the app. So users are encouraged to type in their address at this bar up here. Also, you can use your current location. As an FYI, this application is fully responsive. So as long as you have your location services turned on, you can use it on your desktop, tablet, or mobile device. And if you don't know or have an address, you can also just click within the map. So for demo purposes, one of the addresses that I wanted to show you how this works is I'll just be putting in where we're currently located. Cool feature is that it does start loading up some of the suggestions of addresses, so you don't have to actually fully type it out. So once you click enter, it zooms in into the area that the area that you're located in, the reclaimed water service area. A label pops up to further confirm the area that you're in if you just don't want to use the legend. And then the information that shows up on the left-hand side is particular, dynamic to that area. So you have your provider, your facility information, and other details here. And as you can tell that there are two different areas for professional applicators and for residents. Another cool feature is that you can collapse and uncollapse this information if it's too busy for you. And like Ryan was saying, there's a disclaimer and also a note here telling you that you may live in the reclaimed water service area. Now, what happens if you don't live in an area? Well, the same situation would happen where you still receive a message. Here's another address I'm going to use I know that this is not in an area. You receive a message telling you that you may not live in an area, but get in contact with your utility service provider. And of course, we do redirect you to our homepage at Pinellas County website, letting you know of other ways that you can help protect our local waterways using best practices. So something else I wanted to highlight was that, if you do love our application, which we hope you do, you can easily share it on social media by clicking on these links: Facebook, LinkedIn, Twitter. You can email it to folks. And also here you can get the tiny URL. That's what I like to refer to it as, tiny URL, as opposed to using, this long, complicated one up here. So that's just another, really cool option. And lastly, another really cool feature is this screenshot here feature. You can, if you wanted to, you can take a screenshot of your results. Actually, I'll go ahead and do a demo of that so you can see what that looks like. And you can choose to include the legend or the results, all that information. I'm going to go ahead and say horizontal. You set the map area like that. And this is what it would look like once you download it. This is just like a, and I'm not sure, how you guys can use this, but we figured, why not? Maybe you want to print this out and send it to somebody for documentation purposes. And that's it. And actually, I'm sorry, a couple more things. Another thing that we are working behind the scenes is we are aligning with the county's commitment to improving accessibility of all of our applications, Pinellas County. So for example, some of the things that we have been working on are using color ramps that are great for colorblind, that are colorblind friendly. Not just on our symbology, but also with labeling as well. And there's other behind the scenes features that we're also incorporating, such as inserting alternative text so that for those that use screen readers, they can better like navigate through the application. All right, that's all I have. Is there any questions, or Rob, was there anything that I missed that you want to chime in with?
Nope, you covered everything.
Awesome.
You did great. Thank you, Daniela, for the show and tell. That's awesome. And like we said, Daniela actually put this link in the chat, and it is available right now, publicly available until 10 a.m. tomorrow. So you have some ability to click in, and by all means, we're looking forward to hearing what you think and how we can expand this to others.
Yeah, thank you so much. This is super cool. You guys have done a ton of excellent work on this since I last saw it, especially on the side of who's the audience and who's going to be consuming this information, and just making the user interface a lot more intuitive with a lot of cool features. I of course have some questions, but I want to pause and let others ask a question first if there is anybody on the line with a question.
This is Mike McManus. I've got a question for Ryan. When you were showing the spreadsheet, I was looking at the different municipalities and the concentrations of nitrogen. And did I see that St. Pete has some really high concentration values?
Yes, they're very, very high because they don't have tertiary treatment. So they actually, if you do normal watering, would exceed the limited fertilizer ordinance and recommendations.
Wow. No, that was really fascinating. I mean, as you guys did a nice job summarizing a lot of data and putting it in a format that I think is going to be quite useful. So thank you.
So I just want to say, I'm so glad that you noticed that, because that is one of the biggest pieces of this for public consumption is to understand how important reclaimed water is. It's a fantastic reuse of our wastewater, but the minimum treatment levels for the state is secondary wastewater treatment, which is what the city of St. Pete uses. They're actually the only provider in unincorporated or in Pinellas County, geographic Pinellas County, that is secondary treatment. All of the others are advanced wastewater treatment. So you'll see that there is still some little bit that can be applied while staying within the IFAS recommendations as well as the fertilizer ordinance restrictions. So yeah, St. Pete has been fantastic in educating us, our partnership with them, and educating in regards to water quality. So we're looking to build on that relationship and get that information out to folks.
Well, to follow up, Emery, so I wasn't clear though, is that table accessible to the public, or how would somebody actually see that those values? Is it linked to the data and the map?
So it's linked, it's through the map. So if you were to put in a search for St. Pete, it will show all zeros for additional nitrogen application. It will show all zeros. Currently, it shows the annual concentration in the existing version, but in the new version, it's going to actually show the load. So people will be able to see right there. So average annual nitrogen concentration for St. Pete is 22 milligrams per liter. And then there will be, I think it's under the professionals is where the load is shown. So I think we're still kind of working this out, but I think what will happen is when they come to this page, ideally, both options will be collapsed. So all they see right off the bat is for professional applicators, for residents. That way they can click on whichever one they want. They can click on both, but it's not too much overwhelming information right off the top. So the load is in there. Where is the load? Is it even in there yet? It might be still a work in progress. Scroll down.
Bottom, Anna, but it
Scroll
right now
down a little.
zero.
There it is. No. So
yeah,
the
it's
load
right there with
actually
the
says,
zeros right now.
yeah, the load is in red, and that's incorrect. It actually says the nitrogen load from this reclaim provider is 0.00. No, it would actually show that number from the table that Michael was asking about. So that's where it would show the 9 pounds. And then underneath it would say additional pounds of nitrogen that can be applied, all zeros. So still a work in progress, but that is where the residents or the applicators would see the total load from that provider. And St. Pete has three different plants. So depending on which polygon you end up in, you'll see those three numbers that were in the Excel sheet that Ryan showed.
No, you guys have done a great job, because what I like is you provide an initial summarization of the data, and then if somebody wants to drill down, they can get you the details, which is something that Marcus has illustrated with some of his dashboards. And I think you guys are doing a great job, so that someone can say, all right, I really don't need to put any fertilizer down.
Thank you. Thank you. That's exactly the message we want to get out there. You know, sometimes as the scientists and the ones in the weeds, as we say, it's hard to step back and see, well, what do we only want to share what they need to know. You know, more is available, but we don't want to overwhelm them with too much data, and then it's a turnoff. So trying to meet that delicate balance.
Any other questions? So I guess it's my turn. So this type of application is super cool because I think it's a great example of how open data can inform public behavior for the improvement of an environmental resource. I think that's exactly what you're trying to do with this. You know, there's unfortunately not a lot of good examples for these types of applications. And if we can have these types of things in our backyard to inform the public as well as applicators, that's fantastic. So, you mentioned one of the main goals of this is to educate the public that, hey, I don't need to fertilize, I could just use reclaimed water. And I think that's a great, outcome for this app to be able to achieve, is education in that regard. The other alternative, looking at it the other side of the coin, is it potentially, highlights operators that aren't necessarily doing enough to treat wastewater wastewater at their facilities. And so that's potentially like sensitive information that some operators might not want to have out in the open in this manner, because it might, bring undue attention to needs for infrastructure development or improvements for wastewater treatment that are frankly expensive, and they might not have the resources to deal with that. So it sounds like in our watershed or this part of Florida, there's at least a good relationship with IFAS Extension as someone you are working with to be able to use this data that they're making available, and I'm sure they're aware, putting out in the open for people to see. And that's fantastic. I mean, that's again not necessarily a common thing to see from people that might be, by making their data available, being open that way, and open themselves up for scrutiny that might not be welcome. So one of the things I was thinking is, in the expansion of this tool to other areas, I don't know if you have an answer to this. I don't have an answer to this, but how would you work with wastewater treatment plant operators to make sure that it's in their best interest to make this information available so that it collectively benefits the environment? How do you achieve that?
That's a great question. It's something that we're in the progress of doing. Every municipality, at least for Pinellas County, I mean, this is us in developing this map. I know there are some variations throughout the region, throughout the state, but we all have an NPDES permit. We're all required to reduce sources of pollution to our waterways. Pinellas County is an aquatic preserve. Pinellas County has a lot of impaired waters. There is definitely the stakeholder interest, even from the point of the plant operator, to be providing the best service, not only to their citizens, but also to the environment. So how we look to get this information out, lucky for us, yes, Pinellas County Extension is awesome. And we have partnered with them from the beginning of this ordinance getting out. I mean, it was the extension, their horticulture extension specialist that helped us develop our landscape best management practices course. So while it's a county requirement, there's still that understanding of the important relationship with the IFAS extension in your particular community and addressing the needs that you need to reach to. So yes, the extension has been using this tool as part of their outreach. So the more info that we provide, and Doris Heitzman is fantastic. She was also in our meeting yesterday to to try to see how we can tweak this, how we can make it more easily digestible. But there's also the individual utility providers, and that's why we've been communicating with them over the years to get the data to put into this. But at the same time, they are our co-permittees on our MPDS permit. So they're equally responsible for addressing impaired water quality within their jurisdiction. And as we all know, watersheds don't follow, there's no jurisdictional boundary specifically in that regard. They cross jurisdictions. So we have to collaborate together. We have to partner together. And utilities do their own outreach for water conservation. So tying that message in of water conservation, and reducing nutrient pollution at the same time, we have a lot of great opportunities to expand this out. I will say, when the ordinance first passed in 2010, the ordinance is pretty complex. There's a lot of pieces to it. So when it came to tackling one piece at a time, it was, making sure your applicators are licensed, making sure your applicators have this type of information, making sure your landscapers understand how grass clippings impact water quality. So here we are, we've tackled those monster pieces that now it's like, okay, while this map was there, now we're able to really focus on it and really get this information out to the public. So there will be a lot more effort on our end to do that. And we were super excited when SwiftMud reached out to say, hey, this is really cool. How can we do this on a regional level? And then DEP, this would be great on a state level, because it's true. We have water quality impairments throughout the state. So.
Yeah, that's fantastic. I mean, from an open science perspective, you follow the breadcrumbs. A lot of it just goes back to open data. And there's many reasons why people may not want to share their data, but I think just like you said, the important message that, we all have a collective interest in protecting these resources, whether it's a quantity or a quality issue. And if we can do that through being more transparent and sharing the information that we have for the collective benefit, I think everyone wins. I mean, that's my idealistic perspective, and unfortunately not everybody sees it that way, but that's a good angle, I think, for getting people to get on board with these tools. And it sounds like that's exactly what you're doing. So
it's absolutely right. And you cannot deny the tourism dollars that come into our state because of our environment. So we are protecting our own economy at the same time, because we see the impacts right now, from red tide. It's just, It's a seasonal thing. It happens. It's naturally occurring. Can it be made worse? Absolutely. So, being able to have those seasonally appropriate messages, where people, out of sight, out of mind. So yeah, we're trying to tag team on to what's happening, what people are aware of. Oh, by the way, did you know there's this tool that will help you, help us, help our environment?
Yeah, and that's another good point. I mean, right now, things are very much in sight and in mind in terms of what's going on with the Bay. And we have a really good opportunity to link tools like this to what's happening now. These things aren't isolated events. And if we could raise the awareness about the importance of reclaimed water and how that could reduce, fertilizer use and what that means for water quality, and linking that to other things that are happening, I mean, it's a great opportunity. So yeah, very timely.
Well, thanks again for allowing us to share this. I really hope, I mean, I know for us, we have Esri, we have Rob, we have Daniela. We're going to move forward with getting this out there, probably ballpark October-ish, because we still have to go through that ADA compliance review. We're still getting the newest data from the providers on concentrations for 2020, so that we can put out a more recent product. And then hopefully it's something you can help our partners share somehow through the Open Science Committee. If they don't have Esri, how can we help them do what we're doing here in Pinellas? So thank you.
Yeah, no, thank you. If people have comments, I assume the email contacts that are in the PowerPoint, they can email anybody and everybody.
Absolutely. We would all be happy for any kind of comments or questions, whether it's content on the map specifically or outreach messaging or any ideas. One of the things that DEP was asking was the visualization. They wanted to see, like, you know, if I should put, you know, like 1 pound of nitrogen, maybe show 1 bag, or 2 pounds, show 2 bags. Well, obviously there's a lot of variation in composition of products. So we're not sure how to meet that visualization piece other than the polygon of where you live. So yeah, happy for any feedback. Thanks
Okay.
again.
Yeah, and that all the presentations for today are in the folder that should be shareable and viewable by everybody. So if you want to get in touch, you can check the slides there. So with that, we are right on time. I just want to end with some announcements on upcoming trainings. Again, I've mentioned this before that we are going to have 2 opportunities for open science training that are of regional importance to this group. Myself, along with Chris, who's on the line, we're going to be giving 2 trainings. They're going to be the same, but in different venues. The first one will be at the BASIS meeting coming up in October. This particular one will be on October 18th. That's a Monday. And I believe registration is open now for BASIS. So spots are limited for this training. So if you are planning on attending BASIS, I'd suggest you register now and register for the workshop, because we're limited to, I think, 35 or 40 seats at that training. But what we want to do with this training is just introduce core concepts of open science for more impactful research. And so if you did attend our open science training back in 2019, it'll be a step beyond that and hopefully give you some more hands-on tools that you can use to bring open science to your organization. We'll also be doing that same training at SURF, a national venue, in November. So about a week or 2 after the BASIS meeting. So we're not going to reinvent the wheel there and just repeat that training. But that'll be another opportunity if you are attending SURF to attend that training as well. We also, I did want to close by, we have an open science subcommittee meeting on the books for November 2nd, which is actually going to be a day after the open science training at SURF. I'm actually going to elect to cancel that meeting in the interest of everything else that's going on around that time of the year. Unless I hear strong objections otherwise, I'm just going to punt that next meeting till 2022, which brings me to scheduling for next year. So it's August, and we're talking about 2022 already, but I'm probably going to send out a poll of potential dates for 2022 subcommittee meetings for the Open Science Subcommittee. Again, unless I hear otherwise, we're going to continue to have these meetings quarterly, but now that we're rescheduling these things, now is your opportunity to let me know if there's a way that we can do these meetings differently, either through scheduling or content. I'll probably put out a poll and a survey where you can have a chance to enter those comments, both on scheduling and what we've been talking about. So with that, thank you all for attending, and we'll look forward to hearing from you about upcoming meetings. Thank you all. See you next time.
Thank you.
Thanks.